Welcome to Consumer Goods Analytics.com. This is Santiago Restrepo, and today I will be showcasing an advanced analytics case study that's called Did That Test Work?, which is an awesome way to analyze if a test worked in some of your retail stores. So let's start with the test overview. We had a series of new SKUs that were launched here around week 26 of year 2. And we have also some older SKUs that have been present in the marketplace from a long count. And from a store perspective, the new test stores are around 115 test stores, while the rest of the chain has around 1,000 stores. So it's a small test, and what the retailer or consumer goods manufacturer want to test is to understand if by adding the new SKUs, the whole category grew in terms of dollar sales and in terms of average price. Now, before showing how to analyze the methodology, I'll showcase a few examples how a lot of people analyze cases like these. For example, a lot of people just look at the sales of the whole category in the test stores, and they see that the tests were growing, and once the new products were launched, which is during the test, the product sales decreased tremendously. So if somebody saw this type of analysis, they would say that the test was not successful, and they'll just stop the test and not expand it to the rest of the chain. But these falling sales can be caused by many factors: macroeconomic indicators, changes of weather, seasonality. There's a lot of things that contribute to it. So this methodology is really not robust, it's not recommended. And as we're going to see later on, this test was actually very successful when we analyzed and applied the right methodology and framework. But if you use some of the basic, more traditional methodologies, the test is likely going to show that it was not successful. So I'll challenge you to go ahead and try it yourself. Go to our website, download our data set, and try it yourself and see if a test that started around week 25 of year 2, would you qualify it as a successful test or not, and give that to your analysts as well and see what they say and what they do, and hopefully you get the right answer that the test was good. But if you don't, then maybe you should start using our methodology here or something similar to what we suggest. There's other common examples here in basic method 2 and basic method 3 that also implied that the test was not successful. I won't get into a lot of details in this video. You can go to our website and interact with the visualization yourself and understand it better. But these other two basic methodologies also say that the test was not successful, and as we're going to see later on, the test was indeed very successful. So the next step is to look at the open and closed stores. The stores that are just open or closed add a lot of variability and complexity to the analysis. So what we recommend is doing a store count for each of the periods to understand which are the new stores, which are the ones that closed, and which ones are the active ones. And only the active ones should be included in the rest of the test. The new and the closed stores should be eliminated. And this is a helpful visualization that shows how to select the stores that are open or closed based on the count of weeks. And when you select them, they show here in the right. It's a little bit interactive, and you can go back, select the new stores, the closed stores, and a few of the active ones, and that's how you're able to determine which are new and which are closed. The next step is identifying 3 or 4 different metrics that identify a store. In this case, we looked at the slope, store sales, and percentage of high income, but you can select other ones. And basically here we're looking at the slope of a store, which is 13 weeks before the test starts. Are the sales increasing or decreasing for the specific stores? By how much? Or are they pretty stable? This is a pretty busy chart. The objective is not to visualize the information. The objective is to look at the trend line and get the slope of each of the stores. And when we scroll over the lines, we see that there's an equation for it, and it provides the slope for each of the stores, which we're going to use in the analysis later on. The next store characteristic that we used is the total amount of sales during that 13-week period before the test started. And as we see, there's a lot of variation. There's some of the stores that sell $6–8 million during that period. There's some of the smaller stores that sell $700–800,000 during that period. So it's very important to quantify the store sales and use that as one of the store characteristics later on. The third one that we're using is the percentage of high-income consumers around each of the store. In future case studies, we'll show you how to understand the percentage of high-income and other demographic characteristics around stores. But as we can see here, the test was performed in more stores that are geared towards the high end, where there's more consumers that are a high income than the rest of the chain. So that's another reason that it's very important to use the methodology that we're showcasing here, because if you only looked at the test stores and compare those versus the rest of the chain, the test stores are highly skewed towards higher income areas. So you're not going to be able to read out the test the right way if you compare versus the rest of the chain, because the store characteristics are not the same. Then we're going to do some outlier analysis. Outliers affect the clustering algorithm that we're going to do here in a little bit. And so we need to determine which stores are outliers, and we need to take them away or remove them from our analysis. So we have the point of sale dollars for each of the stores. We have the percentage of high income, and the color is based on store, and here we have the slope, and the color is based on the percentage of high income. And we see that these stores here towards the right are huge outliers. Their sales are way more than normal, so we actually excluded that from the analysis. And this store over here, the slope is also pretty high, even though here in this chart it doesn't look as an outlier. The store is pretty high in terms of slope, so we actually removed that from the analysis. So we removed a few stores to be able to implement the clustering algorithm, which is the next step. So this is the outcome of the clustering algorithm. You're going to need a statistical package or software to develop it. And what a clustering algorithm does is look at different variables. In this case, we have the 3 that we talked about, and try to group stores that have those same similar characteristics into one of the clusters. It's hard to visualize here. We'll show it better in the next slide, but I just wanted to show the output of the statistical software here. So let's look at the output of the clustering algorithm. These are all the different clusters. We created 6 clusters, and you can create, we recommend between 4 to 8. And we can see all the different clusters and how they are identified. So if we click on cluster number 2, which is the green one, there are stores with a higher percentage of high income consumers around them. The slope is pretty flat, it's close to 0, and the sizes of the bubbles are very small, so they're small stores. So that's how cluster number 1 is identified. If we look at cluster number 6, that one has stores that have a less percentage of customers that are in the high income. The slope is a little bit higher, and they're a bigger circle, so they're stores with more sales. So each of the clusters has its own characteristics, and that's the beauty and how the clustering algorithm helps us to determine which are the stores that are the similar stores. In step number 6, we try to understand the composition of the test stores and the rest of the chain. So we see, for example, that test stores have a lot of their stores in cluster 1 and 2, while the rest of the chain has most of their stores in clusters 3, also 1, 4, and 5. but like cluster number 2 is very important for the test stores, it's not very important for the rest of the chain. So what we do is we select the control stores from the rest of the chain, and we do this randomly so that the composition of the clusters is the same in the test stores and the rest of the chain. So now we do have the test stores, there's 73 in cluster 1, and in the control stores we selected 73 stores randomly. Cluster number 2, there are 25, in the rest of the chain we selected 25 randomly, and the same for each of the clusters. So now we have the same number of stores in the test stores and the same number of stores in the rest of the chain, and the stores that we selected have a pretty similar composition. So now we're going to be comparing apples to apples. So now let's look at the actual result of what happened. So here we have before the test and during the ramp up, and the test stores are the blue lines and the control stores are the orange lines. And we here calculate the percentage of difference versus test and control. The average of that is 0. In average they perform about the same, and we see that the two lines, the orange and the blue, are pretty close to each other. And what we want to see is when we click on during the test, we want to see the two lines diverge in order to quantify that the test has been successful. So let's go ahead and see what happens. So yep, that's what happened. During the test stores price was higher than the price of the control stores by about 6%. So it does show that the test was indeed very successful, and we were able to get a better pricing for the overall category. Let's look at what happened with dollar sales. Same story here. The lines for test and control are pretty similar before the test, and the average difference is 0. And when we click on during the test, there's also that diversion between the test and control stores, where the test stores are higher by around 7 or 8%. So it shows that the test was very successful. If we didn't do this methodology this way, we would see that the sales declined here for the test stores after the test got implemented, and we would say that the test was not successful. But as we showed in the beginning, that's not a really good methodology to evaluate a test like this. And then let's look also at unit analysis, not only dollars. We see the same thing. Test and control lines are pretty close to each other. Percentage difference is 0. And here during the test, unfortunately, the unit sales did not increase a lot, but it doesn't really matter. Or our objective for the test was to increase dollars and increase average price. And if we were able to do that and the unit sales stay pretty constant, then it shows that the test was very successful and it met our criteria. The last thing we can do is expand the test. So we can see that cluster number 3 was the one that showed the biggest difference between the test and control stores during the test period. And so it grew about 35%. Cluster number 4 grew about 30%. So if we want to expand the test to other stores, then we would likely be more focused on the first 3 clusters that had a lot of growth, and we likely won't expand the products to these other clusters 5 and 2, which did not show a lot of growth. That's all for today. We hope you enjoyed this case study. Please visit consumergoodsanalytics.com for a lot of great information, including the data sets, more details on the case study, the files, a list of preferred vendors, and a lot of more great information. And remember, if you are not doing these types of analytics, your competitors probably are.